चलो deciding beta concept of polarization. Concept of polarization. Okay. Before that, we'll try to see that what exactly is a light. Light is nothing but what beta? An electromagnetic wave, isn't it? I told you that light is an electromagnetic wave. Is an electromagnetic wave. Electromagnetic wave means it is a combination of electric field vector, electric field and magnetic field vector and magnetic field vector, which are mutually perpendicular to each other. Which are mutually perpendicular to each other. Perpendicular to each other. Okay? So what is a light? Light is an electromagnetic wave. It is a combination of both electric field vector and as well as of your magnetic field vector, which are mutually perpendicular to each other. Something like this. If this is a propagation of the wave along x-axis, this is your y-axis, and this one is perpendicular to this one, z-axis. Angle between everywhere is 90 degrees. So if a wave is being moving in this direction right now, some of the waves will be moving in the upward direction like this. A wave is moving like this. This is moving along your which direction? X-axis, like this. And there is another wave which is perpendicular to each other right now for me. So if I'm talking about this wave, there is a wave which is moving perpendicular to this one like this. Okay. So that means electric field vector is along y direction like this. The vector of this one is right now for me in y direction. Arrow mark is in this one in y direction. Whereas magnetic field vector, if I am saying this vector is like this one, this vector is like this one. Here it is right now like this. Here it is like this. And here it is like this. And here it is like this. And here it is like this. Am I clear? So what is a light? Light is an electromagnetic wave. It is an electromagnetic wave combination of both electric field vector and magnetic field vector, which are mutually perpendicular to each other. Like say if I am taking this one as electric field vector, this will be the magnetic field vector. So angle between them will be equal to 90 degrees right now. Am I clear? So E is right now for me electric field vector. This is your electric field represented by E bar. And this yellow wala is your magnetic field. And this is your magnetic field. And propagation of the wave is along x-axis. This is the direction of your propagation. This is your direction of propagation. Direction of your propagation. In which direction? X-axis. In the direction of your x-axis is your propagation. Am I clear? Am I clear?
Yes.
Isn't
Yes,
it? That means we are having one vertical plane and we are one horizontal plane. Both of them are mutually perpendicular to each other. Now electric field vibrations are visible to eye better. हम जो देखते हैं light का form, electric field vector, this is visible. This is your visible for vision. Magnetic field नहीं दिखता अपने को. So can I say that electric field is dominating the magnetic field? Electric field or magnetic field में who is dominating means what you will say? Electric field is dominating. Electric field is dominating what? Magnetic field. Who is more means what you will say? Electric field is more compared to the magnetic field. Am I clear?
Yes, sir.
Isn't it? So who is responsible for the vision? Who is responsible for the vision? Electric field vector. Electric field vector. Am I clear?
Yes, sir.
That means in simple जब अपन देखते हैं basically whenever we see a pure translation motion. The wave always travels in which direction beta? In transverse wave. This is your transverse wave. Matlab, the wave will be only along your y-axis. So this will be the propagation of your wave like this. So this is your plane which you need to see, right? For wave propagation. Okay. So electric field vector is in the upward direction. And here it is your y. This is your x. And this is your y. Okay. Magnetic field अपने को नहीं दिखता तो इसको हम लोग will try to represent it something like this. So the one which is not visible, this is the dot. And the plane of the vibration will be equal to arrow mark like this. So this is your arrow mark. Am I clear? So
Yes.
we're having the dot and as well as of your arrow mark part of relation. This arrow mark represents me the plane of oscillation. It is your plane of oscillation. Am I clear? Plane of
Yes,
oscillation. Okay. That means it may be an x-axis, y-axis, and it may be your z-axis. Like say a wave may be going like this, or it may be like this, or it may be like this. Right now. Done. Tell me what is the common source of light, beta?
Sir, good evening, sir.
Good evening. Who is this?
Sir, Nayan.
Sir,
I'm from Sri Chaitanya.
Okay, fine. Sure.
Yes, sir.
So what is the polarization I told you, beta? Polarization is a combination of both electric field and magnetic field vector, and a wave always travels in the form of a transverse wave. So it is along your y-axis. Electric field will be along y-axis, magnetic field will be along your x-axis. Now tell me what is the common source of your light? Anyone? So if I'm talking about your common source of light, isn't it? It may be our sun, or it may be an incandescent bulb for us. It may be an incandescent bulb, or it may be a candle flame. This is also a source of your light, or it may be a fluorescent lamp. Fluorescent lamp is the lamp, the bulb which we keep in our houses. In all this one, the light is going in the form of your right now like this. In all the directions, the light will be going in the form of your circle like this. Both incandescent, candle law, and fluorescent part. Okay. So common source of the lights are right now for me incandescent, candle flame, and fluorescent. Okay. Now in this one, we need to remember two things, beta. One is your polarized light. Another one is right now for me unpolarized light. What do you mean by polarized light? Right here, see. First one is unpolarized light. Unpolarized light. Yani the light which is having more than one plane is called as of your unpolarized light. So I can say that light beam which has vibrations in more than one plane. More than in one plane is called unpolarized light. Is called unpolarized light. Am I clear? It is called as of your unpolarized light. Unpolarized light representation. Do anyone remember it? It will be a dot like this and an arrow mark like this. If you see this diagram, this will be representing me what type of a light? Unpolarized light. If there is a dot and as well as of your arrow mark like this. This is your unpolarized light. Am I clear with unpolarized light? Light beam which has the vibrations in more than one plane is called as of your unpolarized light. Like see, in the pure transverse wave, if I'm taking right now for this one, so the plane is right now for me like this. This is your plane like this, in which this wave is been present. In which direction? Y direction. It may be in negative Y, it may be positive Y. So this is one plane of vibration. This is your plane of your vibration. Am I clear? So what do you mean by unpolarized light, beta? Unpolarized light is nothing but the light which is having the vibrations in the light beam which has the vibrations in more than one plane is called your unpolarized light. The symbolic representation of unpolarized light is with a dot and arrow mark. Am I clear? Am I clear? Sure.
Right. Yes, sir.
Next one is polarized light. What do you mean by polarized light? Polarized light means the light which is having the vibration only in one plane. This is next heading is polarized light. Okay, so I can say that a light beam which has vibrations, in only one plane, one plane is called polarized light. Is called polarized light. That means it is only like arrow mark like this, no dot. Okay, I can even draw like this. This arrow mark like this. It may be like this, any plane like this, or it may be like this. But there is no dot. That is called as a pure polarized light. Am I clear? I hope you got a clarity between polarized light and unpolarized light. So polarized light means a light beam which has a vibration only in one plane. One plane is called as a pure polarized light. Am I clear?
Yes, sir.
Sure. This is your unpolarized light, and here there is a dot. Okay. This straight line is called as what for me? Vibration in plane of paper. In plane of your paper. Okay. And this dot line, whatever you're writing, this dot is right now for me what? This is your vibration in the direction of, or in the direction which is perpendicular to plane of paper. Perpendicular to plane of paper. That is your polarization. Okay, so straight line represents my vibration in your plane, and the dot represents me the vibration in the direction which is perpendicular to the plane of your paper. So I hope you got the terminologies on this one. So now see, let us try to talk about your polarization of your light. What do you mean by polarization? Means either having only electric field vector or having only magnetic field vector is called as of your polarized. So for that one, we are using a crystallographic axis, but like say we are having a crystal like this. Okay, and there is a small axis which has been passing through this one, an opening like this. Okay, and a light has been incident on this one. What type of a light? Unpolarized light. Dot and arrow, dot and arrow, dot and arrow is being incident on this material, which is some zigzag type of a shape in the form of your pentagon. This one we are calling it as of your polarizer. Okay, and this axis is called as right now for me crystallographic axis. Okay, crystallographic axis. Okay, so now see when unpolarized light, now this is an arrow mark right now. So this is a light which has been passing like this. The moment which passes through the polarizer, this is your unpolarized light. When unpolarized light is being passed through the polarizer, we are getting an output only with your arrow mark, but no dots. So this light is called as right now for me what? Pole. Is called as of your polarized light. What type of a polarized? It is a plane polarized. Am I clear? So this is some material beta. This is some material which is made up of, I'm writing right now. See, this is some material which is made up of certain material, which is having a property that it will block the magnetic field and it will allow only the electric field access to pass through them. Such type of materials we are calling here as of your polarizers. We are not going much detail. Again, will take much amount of your time. So I'm not going through that. But you just remember that polarizer is a material that which can stop the magnetic field vector, that is the dots, and it will only allow the plane polarization of the light to pass through them. Okay. So can I write the definition here right now, beta? So the definition says that the phenomenon of restricting the vibrations of your light to particular plane which is perpendicular to the propagation of light. Propagation of your light is called polarization. Is called as what? Polarization of your light. Am I clear? So what do you mean by polarization? The phenomenon of restricting the vibrations of the light to a particular plane perpendicular to the polarization of the light is called as of your polarization of your light. So why I'm doing a little bit detail this one is because for doing the numericals, this terminologies and the way of understanding is very important. That is the reason I'm going for a little bit of an explanation related to the polarization. If I would have been felt that this explanation was not required directly, could have been done with the formulas, I would have been directly gone for the applications without doing much of your theory part. But in this one, understanding the terminology is very, very important. Okay. So now in this one, I'll try to draw some dot lines. You just remember, see here, if I'm drawing the dots like this, which is perpendicular to this one. Okay. I'm lightly giving the shade for this one. Just change this one. Roughly, I'm giving the shade for this one, this total part. You're not required, otherwise directly I can go here. So this, I'm giving a name for this one. Like say this is A, this is B, this is your C, this is your D. Okay, so this plane A, B, C, D here contains what? Vibration of the plane, polarized light is called what for me? Plane of vibration. This one I'm calling it as what for me? Plane of vibration. What do you mean by plane of vibration? The plane in which the vibrations of plane polarized are being placed is called as of your plane of polarization. Am I clear with the definition, beta? I'll write here. What do you mean by plane of vibration? So what is the plane of vibration here, beta? A, B, C, D. The box what I am writing. Okay. So I'll write here the plane A, B, C, and D. Okay. Here that contains vibrations. That contains the vibrations of what? A plane polarized lights is called plane of vibration. Is called plane of vibration. He may ask you theoretical questions with it. So what do you mean by plane of polarization? Means the plane in which the plane of polarized light is being present is called as of your plane of your vibration. Am I clear? Am I clear? Any doubt in this one?
No, sir.
The next one you see. There is one more plane beta which is perpendicular to this one. Perpendicular matlab it will be something like this. Draw the thread. Then this one. So this will be one plane like this. Okay. This one is, say for example, P. This one is Q. This one is R. And this one is your S. Okay. So that is called as of your plane of polarization. What do you mean by plane of Polarization. Polarization means what, beta? Stopping, isn't it? Like say for example, if you do better in your examinations, you will be promoted to the next higher class and next higher class like that. That means you are being every channelly, every exam, you are getting what do you call that one? Polarized. That means by every test you are increasing your performance. You will go from one section to another section and finally you attend to the top sections. That means you're segregating from all the students who are lesser than you and you are getting promoted to the higher class. That is called as of your what? Polarization. A plane of polarization means what? The plane in which there is no vibrations, or called as what for me? Your plane of vibrations or polarizations. All right, the definitions will get a clarity. The plane, what a name I have given, PQRS, okay, which is perpendicular to the plane of vibration. Perpendicular to the plane of vibration is called plane of polarization. Okay, is called your polarization. I can even say with one word in this one to be remembered for competitive examinations better. It is also the plane in which there are no vibrations. In which there is no vibration. And there is no vibration. Is called as what for me? Plane of polarization. Am I clear with these two planes better? One is yellow wala and one is black wala. Plane of vibration means the plane that contains the vibrations. I can say here that contains me right now for me what? Vibrations of your plane polarized light is called as right now for me what? Plane of your polarization. And what do you mean by plane of polarization? Plane of polarization means the plane PQRS, which is perpendicular to the plane of your vibration, is called as of your plane of your polarization. That means it is the plane in which there are no vibrations. Am I clear? Am I clear?
Yes, sir.
So these are the 2 points you need to remember. What do you mean by your polarization and what do you mean by your plane of your vibration? Am I clear? Now let us try to go for the point where we get the numericals. The first point, see here in this one. When a ray of light is being passed through the polarizer like this is your polarizer. When a light is being passed here, this is dot and arrow, whose intensity is right now for me I naught. When it passes through the polarizer, I am getting only the dot. There is only the arrow mark. There is no dot. So here the intensity will become for me I is equals to I naught divided by 2. Okay. So this is your unpolarized light. This is your unpolarized light. When unpolarized light is being passed through this one, this is your polarized light. The intensity become how much for me? I naught divided by 2. Now that to understand whether it is polarized or not, we are keeping one more sheet here, right, like this, which we call it as of your analyzer. Okay, this one is your polarizer. Okay, so whenever the light is emerging better here right now out, so this light whatever is being 10, so this is right now going like this, and these are the vibrations which have been present. Then analyzer will say that, okay, the unpolarized light is not polarized. I'm having only the intensity of your I naught by 2. Because in unpolarized, we are having electric field vector plus magnetic field vector. Now in this one, we are having only the electric field vector, no magnetic field vector. That is the reason it is becoming half for me. So can I say that the emergent ray of light, the emergent light will have no change in intensity, will have no change in your intensity when theta is equals to 0 degrees or 180 degrees. The intensity is how much beta? The intensity is maximum. The intensity is maximum. How much is that? I value will be equal to I naught divided by 2. That means angle between polarizer and analyzer must be either theta is equals to 0 degrees or theta is equals to 180 degrees. Then the analyzer says that the light has been completely polarized. Am I clear with this one? Am I clear with this one?
Yes, sir.
So here also the intensity will become how much for me? I is equals to I naught divided by 2. So now if I change the analyzer angle, this is your angle beta, this is your axis, and this is your axis. If angle between these two axes is 0 degrees or 180 degrees, what is the intensity? Intensity will become how much for me? Maximum. Am I clear? Am I clear?
Yes, sir.
Now see here, one more thing. If theta becomes 90 degrees, theta is equals to 90 degrees, then what happened to the intensity beta? Tell me. This totally I'm turning it by 90 degrees. Then the intensity will become 0. Intensity will become 0. Like say for example, this is an analyzer and there is a hole like this vertical and light is been passing through this one. This light can pass through this vertical slit together. Now if this is been made 90 degrees like this and light is going like this. Now this light will not go out now because it has been now vertical. Analyzer here is right now for me totally blocking. Here intensity will become for me 0. If angle between the polarizer and analyzer is becoming right now 90 degrees. Okay. What will be the intensity? Intensity will become for me 0. Am I clear? I'll write one point here, you see, otherwise you'll get a clarity. When the pass axis of the analyzer is perpendicular to your pass axis of polarizer. So no light is transmitted. No light is transmitted. Okay. So then intensity will become how much for me? Intensity is equals to 0. Am I clear with this one? That means if the angle between the analyzer and polarizer is changing from 0 to 1 degree, 2 degree, 3 degree, 4 degree, 5, 10, 20, 30, 40, up to 90, slowly reduces and finally becomes for me 0. Am I clear? Any doubt in this one?
No, sir.
Sure. Now come to our actual formula on which the problems are being based, which we call it as what? Malus law. Akshara, did you remember what you meant by Malus law? I think the college law. What do you mean by Malus law? See, whenever a completely plane polarized light is being incident on your analyzer, the intensity which is coming out will always become how much for me? Square of the cosine of the angle between polarizer and as well as of your analyzer. That is I is equals to I naught into cos square theta. Let the definition. When a completely plane polarized light when a plane polarized light is incident on an analyzer okay, the intensity what we are getting, the intensity of emergent light, the intensity of your emergent light varies as the square of the cosine of the angle between the polarizer and analyzer. Polarizer and analyzer. Am I clear? When a completely polarized light is being incident on your analyzer, the intensity of the emergent light varies as the square of the cosine of the angle between polarizer and as well as of your analyzer. That is your Malus law. Am I clear? The intensity of the emergent light varies as the square of the cosine of the angle between the polarizer and analyzer. That means the formula will become how much for me? I is equals to I naught into your cos square theta. This is your formula of your intensity. If theta is 90 degrees, then what do you mean by the intensity? Zero, isn't it? Depending upon the value of that one. Am I clear?
Yes, sir.
Sure. Not audible, beta. I was speaking from that time. The connection is little bit
Yes,
broken.
sir. You're
Okay, okay, sure. Let us try to do some problems based on this one, beta. So the first problem, we got two polarites. A and B, which are set in crossed position, which are set in your crossed position. And we got a third polarite. We got a third polarite C is placed between the two, making an angle theta, making an angle theta with the pass axis, with the pass axis of first polarite, pass axis of first polarite. Okay. Now, intensity of light which is transmitted from second polarite, second polarized. Okay. And tell me when it will be maximum and when it will be maximum and minimum. Okay, read the question better. If you understand this question, doing the problems will become for me easy. What are the problems telling? We got two polarites, A and B. I'm drawing the polarites in the form of an arrow mark to understand better. This is the polarite right now for me, A. And there is another polarite right now for me. This one is of here, B. They are in cross position. Cross position means like this, plus like this, or like this. They are in cross position. That means angle between A and B is how much beta? What will be the angle between these two? 90 degrees. Cross means, so initially the angle between A and B are 90 degrees. Okay, and the ray of light is been passing through this one like this. Am I clear? So here the intensity of the light is right now for me I naught. What is telling next one? Two polarites A and B are set in a cross position. A third polarite C is placed between the two, making an angle of theta with the path axis of the first polarite. That means somewhere in between these two, there is a third polarite, which is making an angle between these two is how much for me? Theta. So obviously this angle will become how much better? If total angle is 90, from 90 you take it out this theta. So angle between these two will be 90 minus theta. This will be the polarite C. Am I clear? So we got three polarites A, B and C. Angle between A and C is 90 theta. C and B is 90 minus theta. And angle between A and B is 90 degrees. Am I clear? Any doubt in this?